Hi everyone, my name is Mahender. Welcome to my channel. Today I would like to explain about units and dimensions. It is from 6th class. The name of the topic is units and dimensions. We measure different things every day. When we wake up morning, we see the time, how much it is. Or when you travel from one place to another place, we estimate the distance, how much it is there. So measurement is a part of our day-to-day life. So what is measurement? Measurement means comparing an unknown things with a known fixed unit is known as a measurement. So measurement means nothing but here we can see. So this is a unknown quantity. For example, if we want to measure the length of this object, we have to compare this with known standard unit. So here we are using the scale. Measurement is nothing but comparing the unknown quantity with known physical quantity. So what is quantity? First we have to learn. Quantity means size, amount or magnitude, or simply we can say how much or how many times an object is there. That is known as quantity. Quantity means size, magnitude or amount, or simply we can say how much it is or how many are there. That is known as a quantity. For example, for quantities, physical quantities, area, length, mass, speed, time, force. These all are example for physical quantities. And physical quantities are measurable. The quantities which are measurable are known as physical quantities. Some quantities cannot be measured. For example, love, sadness, hungry, affection, weakness. These are not measured. So these are unmeasurable and these are not considered as physical quantities. Physical quantities means the quantities which are measurable are known as physical quantities. Physical quantities which are measurable. Examples of physical quantities: length, pressure, mass, time, force, area. These all are examples for physical quantities. Again, physical quantities are classified into three types. First one is fundamental physical quantities. Second one, derived physical quantities. Third one is supplementary physical quantities. Let us see first what is fundamental physical quantity. Total there are 7 fundamental physical quantities. The first one is length, second one mass, third one time, fourth one electric current, fifth one thermodynamic temperature, luminous intensity and amount of substance. These are the 7 fundamental quantities. Fundamental quantities means the quantities which are independent. These quantities do not depend on any other physical quantities. It means these are the base quantities. The quantities which are independent. It means these quantities do not depend on any other quantities. Such quantities are known as fundamental physical quantities, are also known as base physical quantities. Length, mass, time, amount of substance, luminous intensity, electricity and thermodynamic temperature. These are the examples for 7 fundamental quantities. These are the 7 fundamental quantities. Next, derived physical quantities. Derived physical quantities are the quantities which are depend on other physical quantities. These are known as derived physical quantities. For example, derived physical quantities area. To find out the area, we need to multiply length and breadth. And breadth means smaller side. Length into length, that is equal to length square. It means To derive the area, we are depending on another fundamental quantity, that is length. That is why area is known as derived physical quantities. And volume also. Volume also derived physical quantities, length into length into length. We need to multiply 3 times. Next, supplementary physical quantities. These supplementary physical quantities related to the angles. For example, here if we see here one circle, the angle which is made by this circle is known as a 2D angle. This is the plane angle unit is radian. So radian is the unit of plane angle. And here the angle made by the sphere. It is 3D diagram. If we observe this second one, it is a sphere. The angle made by this here, this portion is known as a solid angle, and the solid angle is measured in a steradian. There are two supplementary physical quantities. One is a plane angle and another one is a solid angle. Plane angle is related to 2D shapes and solid angle is related to 3D shapes. The unit of plane angle is radian and the unit of solid angle is steradian. Next topic is unit. So what is unit? Unit is the standard measurement of any physical quantity, that is known as a unit. When we measuring a physical quantity, we compare it with known standard quantity. That standard quantity is called as a unit. A unit is an algebraic value, not merely name. It operations apply directly to units. You can see multiplication examples, meter into meter, meter square, and division example, centimeter square by centimeter, that is equal to centimeter. Any physical quantity should be expressed in two parts. So that is, every valid measurement requires two inseparable components. Any physical quantity should be expressed in two components. For example, if you want to measure length of a stick, it is 5 meters. Here 5 is the number, it is known as numerical value, and meter is the unit. So the physical quantity is here length. The length is expressed 5 meters. It means number followed by unit. So any physical quantity is expressed the product of number and its unit. Here you can see one formula, P is equal to, P means physical quantity, it may be anything. Okay, physical quantity is equal to numerical value and unit. For example, if we consider liquids, water, physical quantity, to want to measure the volume, here you can say 2 liters. 2 is the here number, liter is the unit. P is equal to Nu. From this you can write N as a subject of this formula. N is equal to P by U, or U is equal to P by N. You can write N is equal to P by U or U is equal to P by N. From this equation you can observe that number or numerical value is inversely proportional to its unit. Expressing any measurement requires two key components. Those are standard unit and numerical value. P is equal to Nu. Example, mass of sugar is 20 kg. Numerical value N is here 20 and unit U is kg. Invariance of magnitude. The total magnitude of physical quantity remains the same. It means does not change. For example, here you can say P is equal to Nu is constant and N is inversely proportional to U. Numerical value is inversely proportional to unit chosen. N1 U1 is equal to N2 U2. For example, here unit is larger. Unit is larger. then the numerical value will be smaller. Okay, if the unit is smaller, then the numerical value will be bigger. 1 meter is equal to 100 centimeter. Here 1 is the numerical value n1 and meter is the unit u1, and here 100 centimeter is n2 and centimeter is u2 unit, another system in unit. If we compare here, meter u1 is greater than centimeter u2. It means here unit u1 unit meter unit is larger than the centimeter unit, and that's why numerical value 1 is less than 100. So the one number is less than 100. So this is the relation between the numerical value and unit. It means when numerical value increases, its unit will be decreased. Next, the strict criteria for universally standard unit. The unit must be convenient in size and invariable. Invariable means it does not change with over period of time. Any season the unit must be same. In rainy season, winter or summer, the unit must be same, invariable, it does not change. Third one, and ambiguous. It means without confusion we have to express it easily. And imperishable, cannot degrade or expire over period of time, that is imperishable. And last one is reproducible, easily recreated for global usage. So these are the all 5 criteria to express a standard unit. So what we have learned in this topic is physical quantities are classified into 3 categories. First one is fundamental physical quantities, second one is derived physical quantities, third one is supplementary physical quantities. And any physical quantity is expressed by two components, that is P is equal to Nu. P means physical quantity, N means numerical value, U is the unit. And the relation between the physical quantities N1 U1 is equal to N2 U2. Thanks for watching this video.